Welcome back to Unit 2, Lesson 11, Interpreting Graphs of Proportional Relationships. So we're going to start with the warm-up, 11.1, what could the graph represent? Here's a graph that represents a proportional relationship. Invent a situation that could be represented by this graph. 2, label the axes with the quantities in your situation. 3, give the graph a title. And 4, there's a point on the graph. What are its coordinates? And what does it represent in your situation? Pause the video now and take about 2-3 minutes to answer these questions. All right, welcome back. So you could have invented any situation for the purposes of this video. I'm just going to put one that I have. So a possible situation is a car moving at a constant speed. Label the axes with your quantities in this situation. So I would say the horizontal axis, the X would be labeled minutes. And then our vertical axis would be labeled miles. And then I would give the graph a title. So maybe distance traveled by car. Right, and then the last one says there's a point on the graph, what are its coordinates, and what does it represent in your situation? So in this case, it's 16, 12. So my coordinates are 16, 12, and that could represent the car travels 12 miles in 16 minutes. Now yours could have looked very different from mine depending on the scenario that you came up with. This is just the one that I'm using for the warm-up. All right, let's turn to page 150. So Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. The point on the graph shows his arrival at the bumper cars. What are the coordinates of the point? Tell us about this situation. So take a moment to answer this question. What are the coordinates of the point? Tell us about the situation. Great. So our points are 40, 50. So 40 seconds, he traveled 50 meters. So 40 seconds after Tyler started walking, he was 50 meters away from the ticket booth. Number 2, the table representing Tyler's walk shows other values of time and distance. Complete the table and then plot the pairs of values on the grid. So take a moment to go ahead and do that now. All right, welcome back. Let's figure out what our value for 1 would be. So we're going to do, let's say 50 divided by 40 to find our constant speed. So 40 goes into 50 once, We end up with 10 left over. We're going to bring down that 0. 40 goes into 100 2 times. And we're going to get left with 20. Bring down one more 0. 40 goes into 200. How many times? Think about 4 goes into 20. How many times? Goes in 5 times. We end up with 200. So in 1 second, he can walk 1.25 meters. So you should have gotten 1.25 meters. So now we've got to plot these points on this graph up here. So we have 0, 0. We're going to go to 0, stay on 0. 0, 0, that is our first point. 20, 25, we're going to go over to 20. It looks like these are going up by 5. So 5, 10, 15, 20, 25. We're going to plot that point right here. 30, 37 and a half. We're going to go over to our 30. 5, 10, 15, 20, 25, 30, 35. Not quite 40 because it was 37 and a half. So we're going to be somewhere in the middle. We can just estimate this with like right about 37 and a half. So it needs to go up. So ignore this one. This one isn't a spot. All right, 40, 50, and then we had 1.25. That one's going to be a little tricky to graph. So now let's look at number 3. What does the point 0, 0 mean in this situation? Take a moment to answer that question. All right, welcome back. So what does the point 0, 0 mean in this situation? Well, at this point, no time had elapsed and he had not walked anywhere from the booth. So no time has passed. And Tyler's at the booth. Number 4, how far away from the ticket booth was Tyler after 1 second? Label the point on the graph that shows this information with its coordinates. So if we're saying this is about 5, we can divide this into 2 about 5. And we can do the same thing here. So this first point would be about right there. Number 5, what is the constant of proportionality for the relationship between time and distance? What does it tell you about Tyler's walk? Where do you see it in the graph? That's kind of a big question. So take a moment or two to think about that and come up with your answer. All right, welcome back. So if we're looking at the graph and we're looking at this first point here, we know this is at 1. So each second he's walking about 1.25 meters. So the constant of proportionality is 1.25 meters. Oops, you can't see that. Actually, you don't even need that point. Is 1.25 because he moves 1.25, so 1.25 meters per second. All right, let's turn now to page 151. Right, 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Plot a point that shows the number of seagulls and the amount of garbage they ate. Use a straight edge to draw a line through this point and 0, 0. Plot the point 1K on this line. What is the value of K? What does the value of K tell you about this context? So this is a couple of parts to it. So there's 3 parts. Let's start with the first one. So plot a point that shows the number of seagulls and the amount of garbage they ate. Well, it says 4 seagulls ate 10 pounds of garbage. And if we look at our graph, we have the number of seagulls at the bottom and the pounds of garbage on the side. So we can say we know there were 4 seagulls and we need to go up to 10 pounds of garbage. So there's our first point. Number 2 says to use a straight edge to draw a line through this point. This is where you're going to take your ruler. We are going through the origin, 0, 0. And we are going to draw a line from 0, 0 up through our point. And then it says plot the point 1K on the line. So, if we have 1 seagull, about how much garbage do they eat? So I can see my point right here. About how much garbage are they eating? So we can figure this out a couple of different ways. One, we can divide, and we can find out 4 goes into 10 how many times? So 4, 10, goes in twice. We have 8, subtract. We have 2 left over. Let's bring down to 0. 4 goes into 20 5 times. So we would have 2.5. This would be 1, 2.5. This one would be 4, 10. But we could also look at our graph and estimate it right here. So this point is about halfway between 2 and 3. So we could say 2.5 pounds. So K equals 2.5. And we can say that the seagulls eat 2.5 pounds of garbage. All right, and that's it for lesson 11. I will see you next time for lesson 12.